Hi everyone, I'm Nayani Rohit. Today I will present my project Serverless Computing Framework with Intelligent Function Placement and Cold Start Mitigation. This is done by me and my teammates Mahiraj Purohit and Sharan MJ and under the guidance of Dr. E. Sujata, Professor, Department of Computer Science and Engineering. Here, the agenda of this session is like introduction, statement of the problem, scope of the project, methodology that contains system architecture, workflow, algorithms used, design diagrams like use case, class, implementation overview, output, results, test cases, conclusion, future work, and references. First, introduction. Serverless computing framework with intelligent function placement and cold start mitigation. So here, serverless computing is a cloud computing model that allows applications to run without managing servers. It enables event-driven execution, automatic scaling, and pay-per-use cost efficiency. A major limitation of serverless platforms is a cold start latency, which affects performance. Cold start occurs when an idle function is invoked and the execution environmental is initialized. This delay impacts real-time and latency-sensitive applications and may cause SLA violations. Our project focus on reducing cold start latency using intelligent prediction and function placement. The main statement of the problem is serverless computing framework with intelligent function placement and cold start mitigation. The challenges are cold start latency. Serverless function will experience delays when it is invoked after idle periods due to environmental initialization. Reactive scaling. Existing platforms allocate resources only after request arrive, increasing response time during traffic spikes. Functions are often deployed without considering user location, data locality, or latency requirements. Objective. Design an intelligent serverless framework to reduce cold start latency using predictive techniques and optimized function placement. The scope of the project serverless computing framework with intelligent function placement and cold start mitigation. The scope is focused on designing an intelligent serverless computing framework, develop predictive models to forecast function invocation patterns, improve performance of latency sensitive applications by reducing cold start delay. The target audience are cloud service providers, developers, and organizations. Deliverables an intelligent serverless framework with cold start mitigation techniques, optimized function placement strategy across edge and cloud environments. Documentation explaining system architecture, prediction models, and performance. Here, the inclusions are collection of serverless function invocations, logs, and usage data, invocation pattern analysis, and workload prediction using ML models, implementation of proactive container pre-warming strategies, intelligent function placement across edge and cloud environments. The exclusions are not covering application level business logic development, no real-time production deployment on commercial cloud platforms. The data. Use historical serverless function invocation logs and workload traces, pre-process data to analyze execution patterns and idle durations, the limitations, resource and infrastructure constraints. Modern generalizability. Prediction accuracy may vary from unseen workloads. Platform dependencies. Performance may depend on underlying serverless platform. Computational resources. Training and simulation may require moderate resources. Here, the methodology of this project is first, data collection. The first step to collect historical serverless function invocation logs, including execution time, frequency, idle duration. This data used to analyze workload patterns. Data pre-processing. The collected invocation data is cleaned, normalized, and formatted to improve prediction accuracy. This includes handling missing values and smoothing workload trends. Prediction model development. Machine learning models such as RIMR and LSTM are developed to predict future function invocation patterns based on historical data. Framework implementation. An intelligent serverless framework is used designed to integrate prediction models with function scheduling and placement mechanism. Integration and testing. The prediction model is integrated with serverless environment and tested to evaluate cold start redundancy and latency improvement and system reliability. Serverless framework workflow includes collection serverless function invocation logs, analyzing workload patterns and usage behavior, predicting future function depending using ML models, proactively pre-warming functions containers, intelligent placement of functions across edge and cloud nodes, monitoring performance and refining prediction accuracy. Here the architecture or diagram or flow. Here the user request like it triggers the API gateway, invocation monitoring module, prediction engine, decision engine, functioning environment, performance monitoring logs, and this whole thing takes place and gives the output. The design and use case diagram. Developer submit function, system of functions. It goes to serverless framework, function execution environment, review performance reports, monitor invocation patterns, optimize function placement. Here the actors are developer or system functions. Use cases are submit function request, monitor invocation pattern, optimize function placement. Here the UML diagram for use case. It all starts with developer admin and goes to serverless framework. Break workload, preform containers, place function, execute functions and logs, manage prediction models, analyze invocation patterns, monitor function invocations, configure function parameters, submit function request, view function execution status. Here the design class. The sequence diagram, how each sequence works and how the project works. The algorithms used. The project uses following algorithms. Autoregressive integrated moving average. A time series forecasting algorithm used to predict future function invocation patterns. It analyzes historical invocation data to identify trends and seasonal behavior, help in proactive resource allocation and content pre-warming, reduce cold start latency by predicting demand in advance, suitable for structured and periodic workload patterns. The project uses LSTM, long short-term memory, a deep learning algorithm used for sequence and time series prediction. Effective handles long-term dependencies in serverless workload data, capture complex and dynamic invocation patterns, improves prediction accuracy during sudden traffic spikes, support intelligent function placement and auto-scaling decisions. Hardware and software selection. The hardware are cloud and edge services, virtual machines or containers, standard CPU and memory resources. Software, serverless platforms like AWS Lambda, OpenFaaS, Knative, Kubernetes for container organization, orchestration, Python for workload prediction models, machine learning libraries like ARIMA, LSTM, monitoring tools for logs and performance analysis. The project implements using Python and serverless computing frameworks. Historical serverless function invocation logs are collected and stored. ARIMA and LSTM models are implemented to predict future function invocation patterns. Prediction results are used to proactively pre-warm containers to reduce cold start latency, and intelligent scheduling module decides function placement across edge and cloud nodes. The serverless framework executes function with reduced startup delay. Performance metrics such as latency, cold start frequency, and execution time are monitored. Here, the important code segments are these are the input datasets. Is a main control plane orchestration, coordinate all components, and runs reconciliation loops. The output. Coming to output, this overview dashboard provides summary of system performance, including cold start rate, latency, total requests, and SLA compliance. It helps monitor overall system health and performance in real time. Visual charts allow quick analysis of latency distribution and resource usages. Next is the functions tab. Here, the function shows what are the functions are active and what are their innovations and average latencies. And the predictions. Here we could predict what is prediction accuracy, the root means error, and for the each function, what is like the predicted invocations within the 20% target. Next is cost analysis. Here it shows how much cost we are saving and what is the cost per invocation, what is the total cost today. And here optimization. So here it will be shown as level 1, level 2, level 3 of the memory, which is being hot, disk, warm, and cold. And based on this, we'll use L1 catch hits, container saved, latency reduced, federated accuracy, active clients, current route, global model accuracy, and based on this, the project runs. These are test cases. How will be action input, expected output, actual result.